Hello and welcome to this really quick video where we're just going to be recapping some circuit symbols from GCSE. Now if you remember from your GCSE physics, every single circuit has to have a source of potential difference, in other words a source of energy. And this particular symbol is one that you'll be very familiar with from GCSE because this is the symbol for a cell. So you can think of a cell as just one, basically it's one part of a battery. And a cell's got two sides to it. It's got a positive side, which is always the long line on this side, and a negative side on this side. So this provides energy to our circuit. So that energy would then travel around the wires and light up a bulb or something like that. Now we can put these things together, and if we put more than one cell together, then we make up a battery. So for example, this thing is a circuit symbol for a battery, and people often get very confused the difference between a cell and a battery. A battery is simply just more than one cell in series, and again if we compare this symbol and this symbol, then this will be the positive side and this will be the negative side. Now both cells and batteries provide a potential difference, and potential difference, if you remember from before, is measured in volts. So that's why it's often called a voltage. The correct term that all exam papers will use it for, they won't use the word voltage, they'll use the word potential difference. Now there's two very important quantities that we look at when we look at circuits. The first one of these is the current. Now the current is measured by an ammeter. And this is the symbol for an ammeter. And as we'll see in another video, in the next video, the current is simply the electricity, how much electricity basically flows around the wires. And in order to measure that, we use an ammeter, and so here we have an example readout of an ammeter, and you'll see that current is measured in amps. So that's fairly straightforward. It's measured in amps, it's measured by an ammeter. Now what is pretty important is that if you want to measure the current, then an ammeter has to be in series with the thing that you want to measure. So for example, if we want to measure the current going through this cell over here, then this ammeter has to be in series. In other words, it has to be in exactly the same line of the circuit. So the current would pass through the cell and then through the ammeter, like that. So they have to be in series with the thing you're interested in, basically. So this thing simply measures the current. So we'll just write that down. So that measures the current going through the circuit. In order to measure the potential difference, we need a different meter, potential difference, and as we've already seen, potential difference is measured in volts. So for that we need a voltmeter. Now the symbol for a voltmeter is this. It's very, very important that when you draw both of these that there are no lines inside the circle. So if you're asked to draw an ammeter, for example, if you do something like this where you put the lines going through, then this will be marked as wrong. You'll notice there are no lines inside either of these things. So this voltmeter measures the potential difference. Potential difference is measured in volts, and so therefore we use a voltmeter in order to measure the potential difference. Now, in a different way to the way that an ammeter is put into a circuit, voltmeters are put in a different way. Voltmeters must be in parallel around the thing that we're interested in. So if we want to know the potential difference across this battery over here, then we would put our voltmeter in parallel like that. It doesn't go in series, so it wouldn't go over here. It goes in parallel instead. And in the next video, we'll have a look and see exactly why that is. So when we draw a circuit, we must have a source of potential difference, and we very often have these meters, but we also have different components in them, in these things too. And again, we need to remember all of these components. So the first one we look at is this thing over here, and you'll remember again from your GCSE studies that this is a resistor, and a resistor basically just gets in the way of the current. So a resistor affects, or it changes the amount of current in a circuit. Oops. So that affects the amount of current. Basically, if you have a big resistance, then you have a small current, and if you then make the resistance get smaller, then the current will get bigger, basically. So resistors are used to control the size of the current in a circuit. Now this is a fixed resistor, so this might have a resistance of, for example, 10 ohms, and the symbol for ohms is this funny horseshoe shape, and you can't change it, so this resistance is fixed. Sometimes that's not useful, because when this is in the circuit, it will affect the current by a certain amount, but you can't change that. You may want the current to be small and then change the resistance to make the current get bigger. In this case, we would use this thing over here. So this is a variable resistor. So basically we can change variable resistor, we can change the size of this resistance. So they often look like this, they often have a dial on the top, and if you turn this dial one way, it'll make the resistance get bigger, and if you turn it the opposite way, it'll make it get smaller. So variable resistors simply means that you can change the resistance. Change resistance. And if you change the resistance, then you can change the current. So that's a manual way of changing the resistance. Again, often we want an automatic way based on, for example, what's going on in the environment. And there's a couple of ways to do that. The first, if you think about, for example, your central heating system, you want your central heating system basically to measure the temperature, and if it's too low, you want the heating to come on, and vice versa. And so for that, we would place this inside a circuit. This is a thermistor, and this is the circuit symbol for a thermistor. And what this does is the resistance of this changes with temperature. So very often, if you have a low temperature, it's got high resistance, and if you have a high temperature, then it's got a low resistance. So the resistance of these changes with temperature. So we'll write that down. Oops, resistance changes with temperature. So that can be useful in things like central heating systems, in hot water systems and things like that. So the resistance changes with temperature. Okay, so basically if you want the temperature to, if you want to do something with temperature, you'd use one of these. Another way to change the resistance by looking at the environment around it is, instead of using temperature, is to use light. Now this is a symbol for it's often for an LDR. An LDR simply means light dependent. So that's a light dependent resistor. And what this basically says, resistor, can't spell. What this basically says is that the amount of light that falls onto this again affects its resistance. So again, if we have a low level of light, if it's kind of dim, then the resistance will be big, and the brighter light that shines on here, then the resistance goes down. So these are used in things like street lamps or those security lights that come on outside your house. So there are different ways that you can change the resistance. So this is a fixed one. You can change the resistance of this simply by turning it, and then these things do it automatically. There are other components that are often very useful. Now, some components, particularly in things like radios and things, only want the current to go in one particular way around a circuit. And sometimes if you changed your battery around the opposite way, it would mean the current would go the opposite way. And if that happened, then your circuit wouldn't work, or you could damage the components. So as a safety device, you can put one of these in. This is a diode. So this is the circuit symbol for a diode. They often look like this. And what this shows is that it will let the current go this way from positive to negative. So the current we say goes from positive to negative. As we'll see in the next video, that's not entirely true. But we think about conventional current going from the positive part of our cell or battery towards the negative part, and if the current goes that way, then everything's absolutely fine. If, however, we turn the battery around so the current's going this way, the diode has got a really high resistance in that direction, and so basically there is no current. And so basically this can act as a safety device. It lets current go one way but not the other way. And again, we'll look at this in greater detail in another video. Another safety feature is something that's in every 3-pin plug in the country, and this is a fuse. So this is a circuit symbol for a fuse. And again, you remember your GCSE physics, it basically just consists of a thin bit of wire, which is what this shows. This is kind of like the casing, and then you see the wire going through it. If the current gets too high, then this wire gets very hot and basically it melts. So the wire melts, it breaks the circuit, and so therefore no current flows, and so therefore you end up with basically your circuit is now safe. So we've got different ways to change the resistance, two kind of safety features, your diode, which only lets current go in one way, and the fuse, which breaks the circuit if something goes wrong. and then we've just got a couple of other things. So this thing is something that's very useful. So if we want to light something up, this is a lamp and this is the circuit symbol for a lamp. So basically it takes the electrical energy and converts it into light energy. So the light energy is given out like that. This is a different type of light. So this is an LED. So this is the circuit symbol for an LED. And LED simply stands for light emitting diode. So basically a light emitting diode is one of these things, and so they only work if you put them in the circuit the right way around. But inside here there's a semiconductor thing, and basically when the current passes through it, then light is emitted. So you can get LEDs of lots of different colours. LEDs are often used because they're much more efficient than old-fashioned lamps. Two other circuit symbols that we don't use very often. This one down here with the M on it, this is a motor. So this is simply something that you'd find in an electric drill or in a washing machine or something like that. And that's just something to be aware of. And then this final one, this is the circuit symbol for a heater. So if you want to heat something up, then you'd put this in a circuit. So you would have, for example, your source of potential difference, which is your cell, and then you draw your heater like this, and then you complete your circuit. That's the positive side, that's the negative side. So that's a very simple circuit that would just heat something up. So that's a very, very quick video of the circuit symbols that you need to know for your exam. So you'll need to know the circuit symbol for a motor and a heater, the circuit symbol for an LED, which is just something that emits light, and a lamp, again, which is something that gives light out. All of these circuit symbols you need to learn. So you've got your fuse, your diode, and then your 4 different ways that you can change the resistance in a circuit. And then finally your 2 meters, and then your cell and your battery. And don't get your cell and your battery mixed up. So that's it from me. That was a very quick video on circuit symbols, and I will see you again soon.